Hi, this is question 3 from the AQA Core 1 January 2012 exam paper. For the first part of this video, I'd like you to try the question yourself. So if you'd like to pause the video and give the question a go. Okay, why don't you manage to have a go at the question? What I'm now going to do is I'm going to give you a hint as to how you can go about answering the question, and rather than just giving you a hint, I'm actually going to help you get started with each part of the question. So for part A, it's asking us to simplify 3 root 2 squared. So 3 root 2 squared means 3 root 2 times 3 root 2, and 3 root 2 is just 3 times root 2, and then I want to times that by 3 times root 2. So you want to think about now what that is going to simplify to. Okay, so that was part 1. Part 2, well, we want to show that 3 root 2 take away 1 squared plus 3 plus root 2 squared is an integer, and remember, an integer is a whole number, and we want to find the value of this integer. So again, to get started with this, well, 3 root 2 take away 1 squared, and it's useful to write it out in full. So we've got 3 root 2 take away 1 times by 3 root 2 take away 1. So that's 3 root 2 take away 1 squared, and to that we want to add 3 plus root 2 times 3 plus root 2, and that's 3 plus root 2 squared. And if we now expand that and simplify that, we're looking for this to be an integer, so we should get a whole number. Just to point out, a common mistake here would be to simply just square that and stick those together. So that's why it's useful to write it out in full. Okay, part B, we're asked to express this expression here in the form m take away root n, and again we're being told that m and n are integers or whole numbers. So I'll just leave a little bit of room there. Okay, so what we want to do is we want to rationalize the denominator. So what we want to do is we want to make this, at the moment it's made up of irrational numbers, we want to make it a rational number. Okay, so a number that doesn't involve surds. Now the way that we do this is if we start by writing the fraction, we want to multiply the numerator and the denominator of this fraction by the same thing, but something that's going to change this into a rational number. And what we want to multiply the top and the bottom by is actually 2 root 5 subtract root 2. And I know if I multiply this by this, that's going to give me a rational number. And because I'm multiplying the denominator by this, I also need to multiply the numerator by this. Okay, so just to highlight the value of this expression, well, because the numerator and the denominator are the same, the value of that expression is just 1. So we're literally just multiplying this expression here by 1, which means that we're not changing it at all. So this is going to give us it in a different form. So what you want to do is finish that off, and then hopefully you'll be able to manipulate it to take it into this form here. Okay, so hopefully that's given you an idea as to how you can start this question. So if you now want to have a go and see if you can finish it off yourself. Okay, well done if you've managed to do that. I'm now going to go over the solution to this question, and I'm just going to use a different colour so we can see the bits that I'm adding in now. Okay, so we had 3 times root 2 times by 3 times root 2, so 3 times 3, we can do the rational number part first, that's the word I was looking for. So 3 times 3 is 9, and then root 2 times by root 2 is just 2. So we've got 9 times 2, and that gives us 18. Okay, so now that's fully simplified, and that would be our answer. Part 2, well, I'm going to work down here, and I'm going to expand this bit first. So depending on which method you use, I'm going to do 3 root 2 times by 3 root 2, and you might notice that we've already done that over here, and we know that 3 root 2 times by 3 root 2 is actually 18, so I can start by saying 18, and then I've got 3 root 2 times negative 1, so that's going to be take away 3 root 2, and then I've got the same over here, negative 1 times by 3 root 2, so that's going to be take away 3 root 2 again, and I've got negative 1 times by negative 1, which is going to give me plus 1. Okay, so that's that part of it. I'm now going to add to it, and we're going to have 3 times 3, which is 9, 3 times root 2, which is plus 3 root 2, root 2 times by 3, which is going to be plus 3 root 2 again, and root 2 times by root 2, which is 2. So that's going to be plus 2. Okay, right, so just move that down. We can now simplify this here. So I've got 18 and 1, so that's going to give me 19. And take away 3 root 2, take away 3 root 2, altogether that's take away 6 root 2, plus, and we've got 9 and 2, which is 11, and then we've got plus 6 root 2. And now that's going to be equal to, well, 19 plus 11 is 30, and take away 6 root 2 over here and plus 6 root 2 over here are going to cancel each other out. So what we're going to be left with is just 30, which is what we were looking for. We were looking for an integer, a whole number, and we've managed to find that. If we would have got something different here that included a surd, then we could have gone back and checked to see where we'd made a mistake. Okay, part B. We started this off and we said we wanted to rationalise the denominator, and we wrote down what we need to do that. So I'm now going to write down what my new numerator and new denominator are going to be. I'll start with the denominator. So we've got 2 root 5 times by 2 root 5, which gives me 2 times 2 is 4, root 5 times by root 5 is 5, so 4 times 5 is 20. So that's those two bits multiplied together. I've also got 2 root 5 times by negative root 2, which is going to be negative 2 root 10. I've got root 2 times by 2 root 5, which is going to be 2 root 10, so I need to plus 2 root 10. And I've also got a positive 2 and a negative, positive root 2 and a negative root 2, that's going to give me, subtract 2 there. Okay, the numerator is going to be 4 root 5 times 2 root 5, which is 8 times 5, which is 40. We'll have 4 root 5 times by a negative root 2, which is take away 4 root 10. that's going to be take away 14 root 10. And over here we're going to have negative 7 root 2 and negative root 2. The product of those will be 7 times 2, which is 14, so it will be plus 14. Okay, and that's going to be equal to, well, if I simplify this here, that's going to be 54 take away 18 root 10. 54 take away 18 root 10. And the denominator, well, these two parts will cancel each other out, and I'll have 20 take away 2, which is 18. Okay, so we're almost done. And notice that the denominator has now become a rational number, and remember we want it in this form. We want it in this form here. So 54 take away 18 root 10 divided by 18. Well, I can do 54 divided by 18, which is going to give me 3. And then I've got take away 18 root 10 divided by 18, which is just going to give me 1 root 10. So that's just going to be subtract root 10. And there you go, there's my answer, where m is 3 and n is 10. Okay, thanks very much for joining me for that, and I look forward to seeing you again soon.